Okay, let's just continue this one. Okay, so I hope you guys understand this idea which was put up here. Do you have any questions? Uh, any addition? Any queries, squabbles, anything? Okay. Um, let us continue then. In this case, let us continue. And maybe let's say, let me use one of the examples that we had. Okay. Let me use one of the examples. We're gonna be using the tabular method from now on. Okay, guys, please give me one of the examples that you did in the previous video, or even in the previous session. Okay. But guys, do you understand how we are doing this thing? Let me use this one. X squared sine x dx. Since you guys don't want to speak to me, it's fine. I'll just continue with what I'm doing in terms of making sure that you guys understand. Okay. So in this case, we've got our u, which is equals to x squared, same thing. And then we've got our dv, which is equals to sine x dx, which is nearly the same thing. Then we know that this becomes our b prime. Okay, so we have got b prime and its antiderivatives, u and its derivatives. Okay, so when we're given something of this nature, remember, we always write the alternating signs by a plus, a minus, a plus, a minus, and so on and so on. I'm stopping it for because we know that the derivative x squared will always go that way for it. So we are going to write x squared, then we're going to have its derivative, 2x. The derivative of 2x is 2. The derivative of 2 is 0. Okay. Then we come this side, we have got sine x, the integral of sine x. Now, guys, you know, most of the time when such problems, okay, but it's fine. I'll discuss that one. Let us just continue. Okay. So, guys, as you know, we have to know what is the integral of sine x, meaning that what is that value that when I say its derivative, it will always give me sine x. It's what? It's negative cos x. Okay, so it's going to be negative cos x. Then the integral of negative cos x is just negative sine x because of this negative. And then the same thing applies. It becomes negative cos x. So we're just gonna write cos x. Okay. So this is a this is a terminating variable and this is a non-terminating variable. Remember, a terminating variable is the variable which, when you find its derivative after some certain times, after some certain orders of the derivative, you're going to get 0. Okay. So if it was x cubed, this was still going to be the terminating variable. This becomes okay. So in this particular case, I said to you, we're always going to multiply the 2, then multiply the 2. Multiply the 2, then multiply the 2. And we're going to multiply the 2, then multiply the 2. Okay. So this means that our solution will become x squared sine x dx. This becomes this times z times z. So this becomes negative negative x squared cos x, then this times that becomes a positive 2x sine of x, and then this times that becomes positive 2 cos of x plus c. Okay, I hope you are finding this activity. And you can go back and check with those problems that, because if I can remember what this was, one of our examples that we had in our session. Okay. So do you have any questions? I know tabular method is very easy and you are very confident about, and I'm happy that you. So you can also check if this gives you exactly. We know how to do that, okay? But if you feel like we should do it together, it's fine. Okay. So do you have any? Okay. Let us take another example. Let me make it interesting. Make it very interesting. Let me make it very interesting. So we don't know how many times. So it's just about 4. Okay. Let me make it a little bit. Let me see. Now I've got x squared ln x dx. Okay. So somebody will say, you said that our solution, our value of u should always be a terminating. In this case, you must always remember that at first, when I introduced this, I said you should always let your u be equals to ln x. This rule does not change. Okay. This rule does not change. Please don't make that mistake of changing this. Okay. It's always going to be like this. You always choose your u to be ln x. In this case, we are going to let our dv be equals to x squared dx, meaning our v prime is equals to x squared. Okay. I hope you are fine with this. So we're gonna have alternating variables. Okay. Alternating signs. Alternating signs. So let me take 2. Let me take 3. Let's see how we can do this one. What is the derivative of ln x? Okay. The derivative of ln x, so we have ln x here, and here we've got x squared. The derivative of ln x is just 1 over x, and then the integral of this one, I think it's 1/3 x cubed. Okay. And then the derivative of this one, this thing can be written as x to the -1. Okay. So this becomes -1 over x squared. As you can see, it's non-terminating because we're continuing to find its derivative. Even if we can find a derivative here, we're still going to continue to find another derivative. This one is going to be a positive 2 over x cubed. And then it's going to go like that. Okay. Now, let us come to this side. This side is very much interesting. Yeah, this side is very much because I want us to understand something. But okay, it's fine. Let me not kill it for us. Let us not kill it for ourselves. So in this case, most of the time we expect here to be 0. Okay, most of the time we expect here to be. And in this case, we are not finding it. You understand? But it's okay. Now let us find the integral for this one. The integral for this one, we are going to have 1/3 outside. Then the integral for this one is just 1/4 x to the 4. Okay. This is very nice. I love such. Now we are going to have a final answer of 1/12 x to the 4. Right. So in this case, I'm not sure if the tabular method is going to work, but I'm trying to see as well if it's going to work. Because I don't have like the perfect examples for tabular method. Yeah. So we're going to have this, and then this will multiply with it. So we're going to have these two multiply, and this will multiply with it. This is the rule that we know. This is the rule that we know. It's the rule that we use the longest time. Okay, but I'm going to have a problem because if I can look at my integration by parts, this should be what? This should be 1/9. But here in this case, I find 1/2. So yeah, there's an indiscrepancy. So I don't know which examples we should use per se, which are going to give us the exact solutions when it comes to the being of the tabular method. But I'm just showing you how the idea works, okay? I'm just showing you how the idea works. So this times that, it becomes x squared ln x dx. So this times that, it becomes 1/3 x cubed ln x, okay? I think we found something like this, okay, in the previous session. So it becomes this times that. So it becomes a negative, which I think we found a negative. But now the difference is now, I think here we found 1/9. Now we're finding 1/12, okay? And then this and that goes, and then we got x cubed plus c. Okay, these things are not terminating in this case, okay? But this solution, I'm finding it because of what do we call this? Because of the previous example that. But I think I'm seeing that this is a terrible example to use for tabular method. So I'll refer to the textbook. I have the textbook here, and let us see what type of examples are perfect for tabular method. Okay. But so far, do you guys understand how the tabular method works? Okay. Since people are not answering, it's fine. It's fine. Let me try and find an example. Let me try and find an example. Okay, now I'm referring to a textbook, for example. Okay. Referring to a textbook. Uh, okay, let us have this example here. I feel like this one is going to be perfect for this. So we're gonna have x squared sine of 2x dx. Okay. So let us have that one. I'll check for another one here. So what will happen is, we know, and we have all agreed that we're going to let our u become the terminating variable, which is x squared. Then our dv equals to sine 2x dx. This is our sine 2x. So we're going to have our alternating signs because we know of x squared, we're going to plus minus plus minus. Okay. Then the derivative of x squared is 2x, derivative of 2x is 2, derivative of 2 is 0. And then now we have got sine of 2x, okay, and its integral is going to be a negative 1/2 cos of 2x. Then its derivative is going to be negative 1/4 sine of 2x, and then its, not derivative, its integral. The integral of this one is going to be negative or positive 1/8 cos 2. Okay, so it goes like that over and over and over and over. So what we're going to have from this one, said you're going to multiply this and that, then multiply the 2 with this, multiply this and that, multiply with 2 with this, multiply this and that, and multiply 2 with this. Okay, now what is going to be very interesting in such question is we have to what we call this. We have to, we can check this solution. Okay, we can check the solution by using the integration by parts. I want us to just extend it a little bit just to see and to convince you that the tabular method and the integration by parts will give you the same solution. Okay, so we have that. So it means that we've got x squared sine 2x dx. This will be equals to this times this times. So this is a positive negative, becomes 1/2 x squared cos 2x. Then we have negative times negative times negative becomes a positive. So 2/4 is just 1/2 negative. So this becomes x sine 2x. Okay, and then this positive, everything is positive. So you're gonna have 1/4 cos 2x plus c. Okay, so this is the solution we're expecting to get if we are doing this thing by integration by parts. Okay, this is what we're supposed to do. So I'm gonna take this and write it here. And then we're gonna do it by the traditional way, that x squared cos 2x as 1/2 x sine 2x plus 1/4 cos 2x plus c. Okay, so we are just checking whether these things, they do give us the same solution. Okay, so let me just grab this thing off. Okay, so we know we have let our u be equals to x squared, and then our du equals to 2x. Then we let our dv be equals to sine 2x. Then we let our v be equals to 1/2 negative 1/2 cos x. Our v becomes negative 1/2 cos 2x. Okay, so this hence becomes now u times v is x squared multiplied by negative that, so I can just have negative 1/2 x squared cos 2x. Okay, so we're gonna have minus the integral of this times this. Okay, oh, I forgot the x, 2x v times du, so it becomes a negative 1/2 cos 2x multiplied by 2x x. Okay, so this can be rewritten as 1/2 x squared cos 2x cos 2x plus 1/2 the integral of cos 2x, or I can just write it as 2x cos 2x, 2x cos 2x dx. Okay, so this becomes now another integration by parts. So we're gonna let p, okay, I've used p, I've used a and b. So let me let, I can't use x, m. Let me use m is equals to 2x. So our dm is equals to 2 dx. And then we let our n, dn, be equals to cos 2x dx. So our n would be equals to, it's a positive, so it becomes 1/2 sine 2x. Okay, 1/2 sine 2x. Okay, Now, what we are going to have from here is negative 1/2 x squared cos 2x, which is the first part. We have already found the first part, plus 1/2. Now, as you can see, the second part, we have got 1/2 and 1/4. So let's see if we are going to get those things, okay? So you're going to have n times that, so it's going to be 1/2 2x sine 2x, okay? Because it's m times n, which is u times u, okay? And then you're going to have minus the integral of v du. So you're going to have 2, and you have sine, this is 2, this is this one. So you're going to have 2 times half is just 1. So we're just going to have 1 because of this 2 and this 1. So you're going to have sine 2x, have our dx. Okay, so in this particular case, we can see that this and this will just give us 1, and then we're going to have negative 1/2 x squared cos 2x plus we're going to have 1/2 x sine 2x, which is this part. Now we found the second part, okay? And then we are going to have this one is going to give us a negative 1/2 cos, right? So we're going to have a plus because the integral of sine 2x dx is going to be negative, negative 1/2 cos 2x. So if it becomes negative 1/2 cos 2x, if it becomes negative 1/2 cos 2x, then it becomes a plus here. And then this half times this half, it becomes 1/4. 1/4 cos 2x plus c, which this thing correlates exactly to this thing. So if you use the tabular method, if you use the traditional method, you're going to get the exact same solution. Okay. Yeah. So I was just trying to prove to you that if you use the tabular method, you use this thing, you're going to find the same solution. Very same solution. Okay, so I hope you guys understand what was going on here, and you guys, if you've got any question, you please, and then you can work with this. Do you have any question? Before we depart, let me take the register of those who attended. Okay, so there's no question. So before we end this session, let me just check. Okay, guys, thank you very much for attending this session. I'll upload the videos of this session. And please do have a blessed day. Take care.
Sir,
Yes,
so when are you gonna upload these videos? Today or tomorrow or anytime?
I'm gonna upload them.
Okay.
Actually, I can upload them now. I'll upload them now.
Okay, thank you.
Thank you very much, guys. Have a blessed day. Have a blessed week. I'll see you on our next session, which will be on Friday. Please take care of yourselves. Please wear your mask, and thank you very much.
Ciao.